This is my presentation portion for test 5, and let's get right on question number 1. Alright, so we're given this equation here, negative 3x squared plus 2x minus 3 equals 0, and we are to find the complex solutions. And I have them written out here. Here's the answer is going to be one of these 4, and we're going to figure out which one that is by using the quadratic functions formula, which says that x equals negative b plus minus square root of b squared minus 4ac over 2a. And so now we need to identify our variables so I can plug them correctly into the equation. This negative 3, that's the a, this 2 is the b, and negative 3 is the c. So I plug them into our equation. X equals negative 2 plus minus 2 squared minus 4 times negative 3 times negative 3 over 2 times negative 3. So now we need to simplify what is under the square root. So 2 to the power of 2, or 2 times itself, 2 times 2 equals 4. That's pretty obvious. And now we need to do 4 times negative 3 times negative 3. You got calculated here. So 4 times 3 negative times negative 3 equals 36. But we need to do 4 minus 36 equals negative 32. So that negative 32 is what goes under our square root. But we cannot have negatives in the square root, so we need to get rid of that negative. To do that, we put I in the equation, because I equals square root of negative 1, and that gets rid of that negative there. So now our equation is x equals negative 2 plus minus I times the square root of 32 over negative 6. But 32 is not a perfect square. That's the word I'm looking for. And we need to find a perfect square. To do that, what we want to do is go to this factor tree here. I made a factor tree of 32. We got 2 and 16, then 2 and 8, 2 and 4, then 2 and 2. So now we need to count the how many factors. So 1, 2, 3, 4, 5. So that means now we have, instead of square root of 32, we have the square root of 2 to the 5th power. But like I said earlier, we need a perfect square, and 2 to the 5th power is not a perfect square. But 2 to the 4th is. So what we can do is split this up into 2 squares. So we could have 2 to the power of 4 times the square root of 2. That is equivalent. And now we have a perfect square as one of our squares. So we can simplify that. The square root of 2 to the power of 4. So 2 to the power of 4 equals 16. And the square root of 16 is 4. So that's where this 4 came from. Now we have x equals negative 2 plus minus 4i to the times square root of 2 over negative 6. Now I'm going to simplify a bit more and get rid of the negatives. So to get rid of those negatives, I look at what I could replace them with. And I see that I have a negative 2 over negative 6. But when I do negative 2 over negative 6, I get that negative 2 divided by 6 equals 0.33, which is the same as 2 over 6. So I can get rid of that negative, and now I have x equals, I can get rid of it because it's equivalent if I put in the positive numbers instead of the negatives, and that's just easier to work with mathematically. So now I have x equals 2 plus minus 4i to the power of 2 over times the square root of 2, over 6. But that is not one of our answer choices. So we need to see if we could factor this equation, and we can. We can factor it by we can factor it by 2. See? 2 goes into both 2, 4, and 6. 2 goes into 1 time, 2 goes into 4 twice, and 2 goes into 6 3 times. So that's how we got x equals 1 plus minus 2i times the square root of 2 over 3, which is answer choice B. And that is the answer to this problem.